Okay, we are recording. So this is the assignment that we have. So basically, they have provided us with two tasks. Uh, One is
For
where
the
we choose
checking,
the
like do
orientations,
you need checking luggage
then
or
we select
is that
support
okay to
structures
not checking
and
luggage?
try to optimize their design.
Okay,
Then
now
we
there is the
simulate it
option
and
for
test
you
how strong the supports
will
are
be like the best
and the
option will be
connections
on
are.
United and
So
United actually.
if I
The detail
just
is sold by
open my
United. It's a
report,
non-stop flight on go
wait,
on the going
just
and
give me a
returning back. It's a one-stop flight.
Okay, so here is my report, and I started with like I divided the whole assignment into four tasks actually. Is it four? Let me just check it once again. Yeah, four tasks. So the first task is the orientation selection,
Like
and for that I've
87
chosen a
for
build
DIM.
volume of 300 by 300 by
Okay.
300 mm.
And
Then I
for the
assume
kit, it would be
wire
like 12.
electric discharge machining for cutting off the build plate. That helps me to keep the height between the
Yeah.
build
For the
plate
adult,
and
it
the
will
part
be
to 1
30,
mm,
86, and
and then
54.
use
Okay.
SS316L,
And
which is
for
used
the
for the process parameters. So this is basically what we do for orientation, the process steps.
child, it is
I'll suggest you to
1292
use,
and
let's just
74
start
cents.
with that.
And for the infant, it is $284 and 72 cents. That's the price of the ticket. Altogether, for all the passengers, it is 2964 and 99 cents.
Okay, now here we did go. Hold on a minute. I'll just have to do this. Just give me a minute. Now it's fine. You can see the screen here, right?
Yep.
Okay. So let's start with a new file actually. I'll go to desktop, assignment 3, make a new folder. Yeah, we can do it here. We just move the models in there. This one. And one more thing, instead of using the STL file, use the step file. If you don't know how to use it, just download that file. Like I have downloaded here somewhere, and then open it. Open it in NX. Do you need me to show you that how to do it?
Is it just you won't use open STL file, you just open it directly?
Yes, I'll show you. Wait. See, this is your STP file. Just download it,
Sorry, okay.
and
We
then
can't, it,
just
it's
go
it's
for
just showing the
compile.
home page of NX.
Yeah, let me start with the build tray. Then I'll open that document, and then I'll just save it as .prt. That's it's that easy.
Okay.
So we have a STL build tray. Let me open that, downloads, change this to all files. This is your elbow.stp. Open it, and it will already convert it to .prt. So then you have to save as, go to your folder.
Custom.
Yeah.
Sorry, we can't see those processes. It's just the screen is just showing NX, the home page for NX. I don't know. Maybe it's from my side.
Oh, All right. See,
Oh, very good.
I'll
It's
just close it
up.
again. You download it from here,
Yeah.
and then you open up NX,
Uh-huh.
Control O, go to the place you downloaded the file, switch to all
Yep.
files from here, and then here is your, sorry, this is your STP file. Just open that, and it was already converted to .prt. So just
Okay.
file, save as, go to the location you want to save that file. I'll save it here. It's
Okay.
already there actually, so I'll just have to rename it to one. And there you have it. That's how you get the .prt file. I'll suggest you to use this file instead of the STL. I'll tell you the reason why. So you add a part here and select anyone. Both are the same. Um, yeah, there you have it. Okay. So now, as you can see, you already have subdivided faces because of the edges. But if you use STL, you don't get these edges. So when you are trying to put supports, you will have a harder time. Okay.
Yeah.
Then you basically, when you need the orientation, instead of going to application and then modeling, you can just stay in additive manufacturing in this application and go to analysis. All right.
Okay.
In the analysis, go to part orientation. It's just the same thing, but it will automatically orient the part for you. That's the
Oh,
benefit of
wow.
this. Yeah. Then go next, next, next. In here, you need to input the parameters of the SS316L. So for
Okay.
that, let's open up a pre-existing file. Hmm, this one seems good. Then when you go to process parameters, select this one and check this. Take a screenshot of this page, close it, and then take a screenshot of not this one. Select this one and then click click it. So these two screenshots will have all the information you need to put in here in this part. This part you
Okay.
get all the information from those two screenshots. I have put
Uh,
those screenshots here as well. If you can see, see we need to put layer thickness. You will find it here. Layer thickness where 20 micrometers means 0.02 mm. Hatch distance is also here. Then hatch length, hatch pattern length. This is it. Scan speed, you will find it here, I guess. Yeah, here. Scan speed. Skywriting time here, and the recoding time, you'll find it here. So you can use these two screenshots to complete this, and then you move ahead, keep it as it is, select the part and specify the orientation. Just click on that key and then go next. Set it to anything you want, high or low. If you want like more accurate results, go high accuracy. If you want quicker results, go low accuracy and just press it. I'm not going to do that, it will take a lot of time. All right, and then when you click on like the 1, 2, 3, 4, you will see that the part is orienting itself automatically.
uh,
All right, then um,
For that also, we have to create CSYS, right? Same as
no,
before.
no. You don't have to.
Oh,
That's the benefit. It will orient the part automatically, so you don't need the CSYs anymore.
okay.
All right. Then what I did was we have see the orientations results. We have it here. You take a screenshot of this because you'll need it in further calculations. Then I showed them how the part is actually oriented. As you can see, there are no CSYs present here. It just snaps automatically. Then I tried the nesting and showed how many parts are nested, not nested, and the nesting
Oh,
screenshots.
what was the build volume? Same as 25, 25, 25?
No, no, I said it here. 300,
300.
300,
Okay.
300. Yeah.
No. Okay.
I selected three orientations. This is, as you can see, somewhat tilted,
Mm,
and the third one is more tilted.
okay.
And then I just go here and conclude that why first orientation is good. I'll just say that it's good for nesting as it nests
How
all
did
the
he,
parts.
sorry, how did he get this graph? Was it from
I
NX?
no, I put it in Excel.
Mm,
Oh,
The this data, like the actual ones,
okay.
these are for the current orientations, the actual ones.
Yeah.
So I just put one by one in Excel and I plotted the graphs for each design.
Oh,
Okay, and also
okay.
this thing, how many parts are nested, I put that as well to get these plots. It's a
mm,
good way to show like how a visual aid, how things are varying. All right. Then I said
Oh,
that orientation one, that is the first one. Where is it? This thing is symmetric about the ZY plane, and that
mm.
makes the part be symmetric as well. I mean, there is no warping outside of that plane. So if the part warps, it will warp in that plane. This means that there uh, there won't be any eccentric properties, if you know what I mean. If you know what I'm saying, I'll just show you. Like, see, can you see this line? The properties
yeah.
on the right side of that line and the left side of that line, the properties of the part will be same. But if it was inclined a bit, as in second or third, the properties on the sides of this line, the one black line, this one, will be different. That is why the first orientation is also good. The third reason is the supports. If you can see, the supports are symmetric as well. So when you remove it, it will put same stresses on both sides. So again, the part will stay symmetric. This is the reason why we go with this orientation. I mean, I go with this orientation. You can explain it on your own. This is how you select the orientation, and then we go to support strategy. Where is it? Okay, support strategy and part quality. So basically, you can show that the NX has a lot of support strategies. But I'll just start a new part again. New, move the part. I'm sorry. Move it upwards a bit. Okay, now we are trying to do the supports. So now if you see, we only have surface partitions because of the pre-existing lines, right? Now I
Okay.
select the part, switch it to automatic and click OK. it further subdivides the faces, and you can see the subdivision over here. Subdivide isoline that gives us separated surfaces. So now we go back, we delete all the supports that were generated automatically, and we create manual supports.
Mm.
Select the part, select the face. Now I can select whichever face I want. See, the automatically one generated these surfaces as well. I'll just select these ones. These are good for me. I can select these, this face and this face. Apply. So that's my block one, and then I go here, select these two faces, click apply. Now the problem with these supports is, wait, I'll just make this go away. Huh. So if you see, this block support is landing on the part that will be already solidified. Yeah, and this is
Hmm.
not yet solidified. Like imagine you're here, this part is already solidified, but this is not. So when you are printing this part, the heat will be transferred to this part, and that will cause reheating of this part, right?
Yeah.
Also, when you look at it from this face, yeah, how do you remove these supports? Because if you pull it in this direction, this will get locked. If you pull it in this direction, this will get locked. In the front, it will lock at the flange. So we need to provide some sort of like ability to remove the supports. So what I did was I just edited this. I moved it 10 mm ahead and 20 mm. Oh, not 200. Wait,
Can we make it as a L shape? No, right.
wait. I'm showing you. I moved it ahead and 20 mm to the top. Click on OK. So now it won't rest on the pre-cured
Oh,
or pre-solidified part, won't cause reheating, and it is
um,
easy to remove. So I'll just grab it here and pull it. It will just
yeah.
break here. Alright. So this is how my support strategy was. You can create your own or just follow mine. Then we go to the simulations. So that's the tough part. See, we create generate simulated supports. Also, the benefit of moving this ahead is all the supports are generated without any problem. All the simulated supports are generated without any issue. Yeah. Then we start the process simulation, select the body, order bed fusion, global settings. And now when you go in here, people are facing problems that wait, I'll do it. Wait, give me a minute. Oh no. Should I remove it? Should I not remove it? I don't have the properties for it. Okay, let's do one thing. Um, yeah. So when you select this, people are getting errors like where is Jamil? Like that one actually. Can you see it? Invalid
Yeah.
material defined on support 4.
Oh, yeah.
So that is because of the message I sent on the group. This message. The reason is that SS316 volume supports one homogenized material does not have the interface properties checked and filled. So what I'm talking about is volume supports one for SS316L. Let me just find it. Yeah, this one. When you go to edit the properties and you go to interface, you will see that this checkbox is not checked for your parameter file. Okay, and it's not filled as well. So you need to check it and put these values, these exact values over there.
How did he find it?
It's in, see, it's not everything, it's not that everything is missing. If you go to SS316 build material, you will find it somewhere here. Yeah, 519 elastic limit. So I just scaled it up to 600 because the same thing happens for Incon. The elastic limit was low and then they just rounded it up to 800. It was about 750 or something. So I did the same thing for this. Instead of 519, I used 600. You can use any value that you want, like 50, 550 or something else. You just need to mention it in your report that these values were not given by default in NX. So we just use these values and that's how we are moving. All right.
Mm.
So two things you need to change is, first thing is the SS316L volume supports, and only in the interface section just check this box and put these values, but both of these values are same, must be same. All right, and then
Yep.
you need to add a whole new material. So how do you add or add a material like that? So you just click here, add a new homogenized material, and then you change this to all other supports. All right, and you name it exactly like this one, SS316 all other supports 1. Okay,
Okay.
so I'll
Hmm.
just show you the properties of that again. So these are the thermal properties that you need to put in. You can pause the video later on. I'm recording it. Am I recording it? Yeah, I am recording it. Yeah. Then these are the mechanical properties and these are the interface properties. These are all calculated based on like interpolation based on Inconel material. So the way it's scaled down for Inconel, I scaled it down the same way. I did not have like time to go into detail, so I just interpolated the values and used it. Then you add that here, you go back and in the edit print jobs, you add that material over here. You just click on add and you will find the same material here. So if I just remove it, you will see something like this. You just add it, okay, and click
Mm.
on it. That's the only thing you need to worry about, and then the other process is just the same. But I'll just do one for you. Hey. Oh, I need to mesh it. Yes, I need to mesh it. Can I do anything else? I'll just load it. I can't load it. Wait a minute, I'll just open up some other file for you. This I'm loading the results right now. So wait a minute. Okay. So when you go to computational options, then the only one thing you need to change is enable support failure modeling. This will simulate your supports as well, and then in the results you will see that you have interlamellar stresses, the option to see how strong are the supports. I go down here to the structural, go to cool down, increment, and here you will find it. The interlamellar stresses after cool down. You can also find it in printing, like at the end of printing, how will the interlamellar stresses vary. So see, as you can see, 801 is your highest stress, and your part was, I guess, 600. So there is a high probability that they are going to break during cool down or during printing. But then you can see that we can compensate the model and reduce the stresses. That's
Okay.
what I did.
The maximum permissible stress is 600, right?
Yes,
It's going till 800.
yes. So it is going to break during simulation
Okay,
and
it exceed. I
printing.
think it exceeds the yield strength of the material.
What?
Does it exceed the yield strength, the von Mises?
Yes.
Okay.
I mean, according to what I have taken. All right. What else is remaining? We have done the support strategy. We did the support strength simulation, and then we are doing design improvements. Yeah. So for the design improvements, I've stated that there are some linear parts which can be reduced. I'll suggest you not to just copy the same content that I'm saying here, because this is individual ideology. You can look for some other parts, like how other ways the parts can be improved. For me, reducing the lengths, these straight lengths was used to reduce the build time significantly. So that's what I've done, and that's it. That's how small the assignment is actually. Yeah. Do you have any more questions? One more thing, one
Hmm.
more thing. I forgot to tell you that. Uh, there are some issues with the volume support as well. So you need to copy these properties there in the volume support. These are the thermal properties for volume supports. You'll need to change it if they are not like this. And in the mechanical, you need to put these values in the interface. You already have it. Okay. So you just need to change two things: volume supports, include interface, and adding the whole all other supports. Okay. Then you won't have any issues then. All right. Do you have any questions?
Yeah.
No.
All right, I'll stop the recording.